parallel to diode. This is a circuit. Here I'll give input and here I'll take output. Now if I give input signal like this, Vi 0 Vm minus Vm T by T by 2 T 3T by 2 like this. Now if I give this input signal to this circuit, then what is the output of the clamper? So like clipper, we have given some steps. Here also some steps you need to remember. So first step.
Sir, can you go to the previous slide?
I'll go. First you see the step. Step 2 follow. In clamper. First step, consider that half cycle of input which will forward bias the diode. First step, if you consider this is positive half cycle, this is negative half cycle, again positive half cycle. So out of that, which cycle you have to consider which will forward bias the diode. This is the first step. Now, second step in forward bias, the capacitor charge and during reverse bias capacitor hold that charge. Okay, that means when diode is forward biased, current will flow across the diode and capacitor will charge. And for opposite half cycle, the diode is off, means the capacitor will hold that charge. Okay, you have to assume that one. Next, draw the equivalent circuit, put voltage, to draw the waveform. Okay, you have to note here during reverse bias condition capacitor does not discharge. Okay, so these three steps you have to follow and you have to make this or assume that during reverse bias condition the capacitor does not discharge. So what is the first step? First you need to find which half cycle the diode is on. During on condition capacitor will charge fully. Then opposite condition, when diode is off, capacitor will, you assume that capacitor does not discharge, it will hold that voltage, and each condition we have to do this. Let me solve one question easily. Now see here, in this circuit, you tell me which subcycle the diode will be on.
So positive oxide.
Positive half cycle. So for positive half cycle, diode is on. So I'll do the equivalent circuit. Pi greater than 0, D is on. What is my equivalent circuit? The capacitor, then diode is ideal, so short, then resistor. So here output voltage V0, this is R, this is C, and positive half cycle means I'll represent minus plus Vi. So during that current will flow. So current will flow means the capacitor will charge. How it will charge? This is plus, this is minus. Let that voltage is Vc. Okay. Current will flow in this direction. Is it clear? Short circuit the diode because diode is on. During that current will flow across this circuit. So current is flowing means capacitor will charge. So I am assuming the voltage which is stored due to flow of current across the capacitor is Vc, and I have represented input voltage or positive half cycle as this Vi, output voltage as V0. It's clear?
Yes,
Doubt.
sir.
Yes, sir.
I want to find out the output. So in this condition, output voltage here to here. That means the point between these two, which is same as these 2 point, which is same as these 2 point. What is the V0? What is my V0?
VI
IR.
VC.
हाँ IR. अच्छे से देखो, इतना सारा होने के बाद अगर तुम IR बोलोगे तो इज बेस्ट.
VI minus VC.
Anyone else? अच्छे से देखो और बताओ.
So VC minus V.
नहीं. I want to find output voltage across these 2 points. So this is same as these 2 points. This is same as these 2 points. Same as these 2 points. What is the potential difference between these 2 points?
VI minus
Zero.
zero. जीरो होगा तो सर करंट कैसे फ्लो करेगा?
तो जब क्या बोला था?
उसमें फ्लो होता है लेकिन हम लोग
When diode is short circuit, short bias, current is flowing or not?
यस सर. यस
Yes,
सर.
What is
sir.
the potential difference between these 2 points? Zero. The potential difference is zero, but current will flow. What is the issue on that? Understood? So V0
Yes,
is
sir.
Yes, sir.
0. That means whatever voltage you are applying, all the voltage will capture by this capacitor. Okay, capacitor is when we give voltage or current, the capacitor will charge. How much it will charge? It will fully charge by Vc. How will know that? Apply KVL in this loop. In this loop, you apply KVL. What will get? Okay. Tell me, what is the KVL? Minus 2 plus
Sir, V minus VC equal to 0.
plus VI. ऐसे नहीं. Here across short circuit 0 equals to 0. So VC equals to VI. Okay. So VC max equals to VM. Understood? Now those who are
Yes.
confused about output voltage is 0, they can also put KVL across this loop. Okay. You get to know. So if you put it like this, see here, if I am putting KVL like this, so when I am moving from here to here, that is V naught, and across this short circuit, that is 0. So V naught plus 0 equals to 0. So V naught equals to 0. Understood? So applying KVL in the other loop, we are getting VC equals to VI. Is it clear to all?
Yes, sir.
So we have found out here output voltage as well as what is the capacitor voltage when the diode is on. Okay. Now we'll go to the second condition when diode is off. When Vi less than 0, then D is off. When it is off, capacitor will remain same. Then off means open circuit. Here resistor plus minus V naught R. Here less means plus minus Vi. Now what I'll put across capacitor, you go to the second point here. In forward bias, the diode, in the forward bias of the diode, capacitor charge, and during reverse bias, capacitor charge. And here also I have written note, during the reverse bias condition, capacitor does not discharge. That means whatever voltage is captured by the capacitor, we assume in the negative half cycle or when the diode is off, in that condition, the capacitor will not discharge. Means it will discharge, but what I assume the time constant is very high or large, so that slowly it will discharge, and we'll assume that the voltage is not decreasing as such. Okay. So have you got this point?
Yes.
The assumption you have to take because otherwise this clumper is not possible. So this assumption we have to take during the negative half cycle or during the off condition of the diode, the time constant is large. Time constant means what? It will discharge. So RC, here capacitor C, and here R, it should discharge through this. So this time constant should be large so that it will be very slowly discharged, and as such it will not significantly discharge. So we'll assume the voltage will remain same. So in the previous condition, what we have assumed plus minus VC. So here also I'll assume the same voltage here. It will not discharge. Is this point clear?
Can you repeat once?
I am saying when the capacitor is charged during the on condition of a diode, whatever voltage is acquired there, that will not discharge significantly in the negative half cycle, and we assume that whatever voltage is there, that will remain same in the negative half cycle. So I have assumed here in the positive half cycle plus here see here plus minus VC I have assumed here. So this same voltage will remain in the negative half cycle. I am not changing that one. Is it clear now?
Yes, sir. Yes, sir.
Now I want to find out, this is the condition. In off condition, diode is off and the voltage across capacitor remains same as positive half cycle. I am giving negative half cycle here. Then I want to find out the output voltage. So I'll put KVL here. If I apply KVL, plus to minus minus Vi plus to minus minus Vc plus to minus minus V naught equals to 0. What is V naught? V naught equals to minus Vi minus Vc. What is minus Vi? That is minus Vm. What is Vc? We have already calculated in the last one. That is Vm. Remains same. So that is your Vm. So minus 2 Vm. Understood? Now again check the step. So this is my question. Input, circuit, then consider that half cycle of the input which will followed by the diode. So first I have taken negative half cycle when diode is on, then apply KVL to find out output voltage as well as capacitor voltage. Then I'll go for negative half cycle when diode is off, and we'll assume that capacitor voltage remains same as it is in the previous case. Then apply KVL and find out the output voltage. Any doubt? Now we'll draw the output waveform. So drawing the output waveform, V naught T T by 2 E T by 2 0. So what we have observed, when Vi is greater than 0, what is my output voltage?
Just 0. 0.
0. So it is 0. Now for negative half cycle, when Vi less than 0, what is my output voltage?
2 minus 2 Vm.
Minus 2 Vm. So minus 2 Vm means this is your minus 2 Vm. Again 0. Again minus 2 Vm. Like that it will continue. So what is my DC level here? Average of this. So DC level is
Vm.
minus V. Minus Vm. Now you see the initial input here, Vm and minus Vm, 0 is the DC line. Now the same graph I am again redrawing here like this. Like this. Where this is 0, this is minus 2 Vm, average is minus Vm. So you just visualize the entire signal is shifted downward by Vm. Yes or no? This is your Vm. If I add Vm plus minus Vm, what is the value?
0.
0. If I'll add 0 with minus Vm, what is the answer?
Minus Vm.
Minus Vm. Then minus Vm plus minus Vm. How much?
Minus 2
Minus 2
Vm.
Vm. That's what we are getting. Here 0, here minus Vm, here minus 2 Vm. You see here.
Yes, sir.
Earlier the signal is changing from here to here. Now it is shifted downward by minus Vm. Not by means it is automatically there. Now tell me the initial input peak and now peak. What is the peak to peak voltage for input signal? You see here, from here to here, my input signal. What is my peak to peak?
Yes,
V plus minus or minus.
understood.
Minus Vm. That is 2Vm. Now here output we have got 0 minus and 2Vm, that is upward downward. So that level is upward or downward. Understood? Now instead of Vm, if I take 10 volt minus 10 volt, the signal is like this. Vi 0, 10, minus 10. Now what is the answer?
2020.
No, 2020 कैसे होगा?
सर ऊपर में शिफ्ट हो जाएगा.
ऊपर में शिफ्ट नहीं होगा.
0
हाँ?
minus 20. 0 minus
0
20.
minus 20. The signal will be shifted downward. मैंने तो सेम लिया हूँ ना, सिर्फ चेंज किया हूँ सिग्नल वैल्यू. इंस्टेड ऑफ Vm इट विल बी, देखो सिग्नल इज.
सर तो 0 कैसे हो गया?
तुम करो देखो.
अरे डायोड ऑन था तो V 0 था ना, V आउटपुट.
ये कैसे आया है तुम्हारा 0? क्या चेंज किया हूँ?
Yes, sir.
इंस्टेड ऑफ Vm आई एम चेंजिंग ओनली 10. सो Vm की जगह में 10 होगा. सो पॉजिटिव हाफ साइकिल में 0 था, 0 होगा, और इसमें Vm की जगह 10 होगा, तो माइनस 20 वोल्ट होगा.
सर समझ गए.
अच्छा, अभी एक काम करो, मैं और एक सिग्नल दे रहा हूँ. सेम इनपुट चेंजिंग हियर. इनपुट को मैं थोड़ा चेंज कर देता हूँ, देखते हैं कैसे कर पाते हो. ये कीपर थोड़ा डिफिकल्ट है, क्लम्पर इजी है. यू कैन सी द सर्किट एंड टेल द आंसर, बट इन एग्जाम यू हैव टू फॉलो द प्रोसीजर. मैं यहाँ पे एक सिग्नल दे रहा हूँ. Here 5 volt, here minus 10 volt. 0 Vi.
वही 0 minus 20.
अच्छा से वही 0 से minus 20
20 हो जाएगा.
डीसी कितना आएगा? अच्छा, जो बोल रहे हैं आंसर उसको देखो कैसे. सिंपली यू कैन अंडरस्टैंड द.
सर एक तो 15 आ जाएगा V आउट.
तुम्हारा यहाँ से पिक टू पिक कितना है?
15 सर.
15.
यस
जो बोल रहे हैं 0 to 20 आएगा, तो उसका पिक टू पिक कितना है?
20.
उसका 20 था.
तो 20. तो मैं ऑलरेडी बोल चुका हूँ तुम्हें, सिग्नल कुछ चेंज नहीं होगा, पिक टू पिक रिमेन सेम, देन ओनली आंसर इज वैलिडेट करेक्ट. ओके, सो तुम्हारा 20 हो रहा है, यहाँ पे 15 है, मतलब आंसर गलत. अभी
0 minus 15.
यस सर, 0 minus 15.
हाँ, 0 minus 15 होगा, क्योंकि VC तुम्हारा.
सर इसमें तो डायरेक्ट भी कर सकते हैं ना सर, माइनस ऑफ माइनस कर देंगे, मतलब 5 minus of minus 10. तो
लेकिन ये प्रोसेस तो फॉलो करना पड़ेगा ना.
यस सर, यस सर, यस.
ये कंडीशन सर्किट, इक्विवेलेंट सर्किट, अप्लाई KVL, फिर उसके बाद ड्रॉ करोगे. सिर्फ सिंपलिसिटी, तुम्हें वेरीफाई करना है आंसर करेक्ट है या नहीं है, जैसे तुम पेपर में कर नहीं पाते थे. तो यहाँ पे कर सकते हो कि एक प्रोसेस है, पिक टू पिक रिमेन सेम, तो एक लॉजिक से तुम्हें पता चलेगा तुम्हारा आंसर सही है कि गलत है, लेकिन करना पड़ेगा। ऐसे तो थोड़ी ना वो 5 मार्क का क्वेश्चन तुम लिख दोगे, ऐसे ड्रॉ कर दोगे तो एक मार्क ही मिलेगा। ग्राफ के लिए सिर्फ 1 मार्क है, प्रोसीजर के लिए और 4 मार्क है। So you can verify VC I am giving 5 volts, so VC will be plus 5 and V naught will be 0 volt। फिर उसके बाद नेगेटिव हाफ साइकिल में तुम्हारा -10 और ये तुम्हारा 5 -15। 0 to 15 means it will be graph will be 0 to -15 as we have discussed here, only the label will change to 0 here -15। Similarly also you can take another question like ऊपर 10 नीचे 5। okay, here you can take 10 volt, here you can take -5 volt and you can proceed with that। now we'll go for another question। so अभी मुझे बताओ ये कौन सा टाइप का क्लैंपर हुआ, पॉजिटिव क्लैंपर या नेगेटिव क्लैंपर, किस साइड में जा रहा है?
नेगेटिव नेगेटिव
साइड में जा रहा है, so that is a negative clamper। now I'll give another question, let me see how many of you will do same circuit, capacitor and diode। here I am connecting a 3 volt battery। जल्दी करो। देखते हैं कौन कर पाता है। देखते हैं।
सर VC equal to 7 volt,
DC equals to 7 volt, ठीक है।
V not equal to 3 volt।
नेगेटिव हाफ साइकिल निकालो।
सर -17।
-17, तो 3 से -17 20 हो रहा है, यहाँ पे 20 है, करेक्ट। so those who have not done, let us see। so what is my condition? Vi should be greater than 3 volt। you see here कैथोड पे लगा है तुम्हारा 3 वोल्ट, एनोड पे उससे ज्यादा होना चाहिए। so Va must be greater than Vk, then only D is on। so Vi must be greater than 3 volt, then diode is on। Vi less than 3 volt, diode is off। तो जब ऑन होगा क्या होगा? कैपेसिटर देन शॉर्ट देन 3 वोल्ट प्लस माइनस V नॉट R 3 वोल्ट प्लस माइनस C VC माइनस प्लस VI। सो यहाँ पे अप्लाई KVL करोगे तो V naught -3 equals to 0, V naught equals to 3 volt, or directly you can take that is simple। then applying KVL here, Vi minus Vc minus 3 equals to 0, so Vc equals to Vi minus 3। so maximum Vc max equals to Vi max equals to 10 minus 3 equals to 7 volt। understood? कैपेसिटर Logically also you can understand 3 volt to spend the diode on. So rest 10 volt out of 10 volt, 3 volt is lost to turn on the diode, means 7 volt will be captured by the capacitor. Understood?
Yes, sir.
Now Vi less than 3 volt. So capacitor when diode is on, off, capacitor will remain same. Plus minus V naught R 3 volt. This will remain same. Vi. So apply KVL minus Vi minus Vc minus V naught equals to 0. V naught equals to minus Vi minus Vc. माइनस Vi मतलब नेगेटिव हाफ साइकिल में कितना दे रहे हैं -10 माइनस ये 7
-17.
हाँ ठीक है.
Yes, sir.
How to draw the waveform? You see कैसे ड्रॉ करोगे? E V naught. So for positive half cycle we are getting 3 volt. So you mark it T by 2 T 3 T by 2 2T like this. So I am getting 3 volt when Vi greater than 3. Then 17. Then again 3. Again minus 17. So this is minus 17. This is 3 volt. This is 0. So this is your output. So entirely the signal is up to minus 17 volt. Okay, 3 volt will be in positive direction. Understood? सबको समझ में आया? Now
Yes,
it is
sir.
easy than keeper or difficult than keeper?
Yes, sir.
Excuse me, sir.
Yes.
So could you please show the question once again?
Question. Here's the question.
Thank you, sir.
Now, those who have understood, you can change the voltage polarity here and try to solve again. Same question, just change the polarity. It is very easy.
Sir, VC 13.
हाँ?
13 आएगा ना?
13, sir.
नहीं सिग्नल कहाँ से कहाँ वेरी होगा बोलो. V naught जब डायोड शॉर्ट हो जाएगा आउटपुट वोल्टेज कितना होगा?
Sir, -3.
वेरी गुड. -3
Yes, sir. -3.
एंड उधर 13 था तो इधर 10 दे रहे हैं 23 -23 इज द आउटपुट. सो -3 टू -.
Yes, sir.
तो भी तुम्हारा 20 हो गया. अभी समझ में आया?
Yes, sir. समझ.
Yes, sir.
And you have to follow the process. If you follow the procedure, small change you will do. This will be small, this will be large, small, large. So here plus, here minus, then here plus, so we will get 13. Here in place of this plus plus minus no instead of this one, it will be 13. So here we got minus 23. Like this. So now you have to then output minus 3. ऐसा होगा तो
Yes, sir.
so you can practice by taking more change in, like I have given 10 volt, 5 volt, plus 5 minus 10, or 20 minus 10 plus 10 minus 20. Non-uniform input signal you can take, and you can change the voltage here also. I have given here plus 3 minus 3. You can take another voltage like this. So if you combine, suppose I'll give here 1 volt. So combiningly it is 4 volt. Okay, like that they will give the question.
Okay, sir.
Input signal, and you can proceed with that. This is the procedure. Okay, and tomorrow, next class, we'll take the other type of clamper. It is shifting downward, that will shift upward. You can also practice that one by taking just a simple change. You orient the diode like this. Okay, then it will be shifted upward. So we'll discuss this one in next class. If you have time, you can practice. So it is quite easier but to clipper. So you can get easily.
Okay.
Attending.
Let me take the attendance. Don't leave.
Yes, sir.
Yes, sir.
All of you have understood clipper, or we'll take another session for clipper. Practice करो, बिना practice के नहीं होगा.
Yes, sir. If after practice we can tell
Sir.
sir one more class or not.
Yes, sir.
You take 1 week time. So when you meet again on Monday, so we'll discuss this clamper, and whatever question I have given, if you find difficulty, then we'll take another session for clipper. Okay.
Yes, sir.
Okay. Thank you. Who was